Hello class, Michael McCarthy with the Harvard Blockchain course, and I'd like to welcome our guest Jim Nasr, who is the Chief Software Architect at the Center for Disease Control. Jim, welcome.
Yes, hi Michael. Thank you. I appreciate the greeting and I'm looking forward to it.
So Jim, tell us, what do you do at the Center for Disease Control that is involved with blockchain?
Sure. Yeah, as you mentioned, my title is the Chief Software Architect over at the what is actually called the Center for Surveillance, Epidemiology, and Laboratory Services. But effectively, really is my job is to help modernize our scientific applications, or what you might consider as our external applications. And that's what I've been doing for the last couple of years. I have a background in as a technology architect and have my own business for many years, essentially building software and building solutions around unstructured data. And that's what I've been doing for the last couple of years. And then specifically with blockchain, really, I see blockchain and we see blockchain as a component within the larger picture of things that help us modernize. So I don't see it as a magical kind of thing that by itself solves many problems. It's part of what I think of as our software theme park, and I have an article on LinkedIn and other places that kind of describe this idea. But nonetheless, I've been looking at blockchain with my team for the last year plus, and it turned out that earlier this year we really got some momentum behind it and built I guess a grassroots initiative to look into it, and that was the start of the blockchain effort at my center.
So before we go into the use case of you actually using blockchain and going through the step one through how it actually came about, can you share with us what you personally feel are the pros and the cons of using blockchain?
Yeah, absolutely. I think there's a number of pros. I think where I start, and this isn't necessarily where everyone starts, but I start with a mental checklist. And the very first question is that, is there a need for trust? Is there a need, for instance, in my world, the currency really is data exchange. And I think of blockchain as a mechanism for change, not just for data, but certainly for physical assets as well. But that's the first question. Do I need to have trust amongst parties that may or may not necessarily know each other, or may not necessarily trust each other? And if the answer is yes, I do need to have trust, that's where I start. And I think that's kind of really kind of works from there. I think in terms of other pros, once the trust question has been answered, then things such as compliance, really kind of come to mind. In my world, as you know, healthcare is highly regulated. Public health is regulated. So compliance to, for instance, data usage agreements is a big part of what I do, or what we're supposed to do as software designers and folks building these applications at the CDC or at other places in life sciences. So, it is possible through blockchain to accomplish compliance using a number of technologies, but certainly smart contracts would be a way of doing it. And then from there, transparency really is kind of a natural spin-off of building compliance, where you can actually show, in what I think of as near real time, measured in possibly seconds or minutes, the compliance through notifications and proactive reporting, right? So I see really compliance, transparency as being what I think of as low-hanging fruit with blockchain. Once the trust kind of concept has been established and that is needed. From there, I think there's a lot of other pros that kind of come into it. I think this idea of a distributed ledger or distributed accounting mechanism of transactions that peers take really anywhere in the world is a very, very useful one, and it allows us to really disintermediate parties that don't really need to be there or are really inefficient or create inefficiencies in the business model, and that actually is the case in public health and healthcare in general. And then from there, you can certainly kind of think about other things such as maybe even automation or other kind of things that blockchain naturally can lead you into, or isn't necessarily just blockchain. Going back to the comment about cons, but there's certainly some cons as well. I think, first and foremost, I don't see blockchain in of itself being the complete answer. There's more, unless you're talking about a fairly trivial use case, and almost none of our use cases in public health or healthcare are that trivial. Or you're talking about, essentially purely kind of financial transactions as you've seen with Bitcoin. it's unlikely that that blockchain by itself is enough. It's definitely a key component. So I think that there's this overhype of, blockchain can do everything and it's magical and things like this. And I just don't buy into it. There's also a tremendous amount of noise right now, which I think really is clouding people's thinking about what is the actual signal. And I think the noise really is about Bitcoin, cryptocurrencies, ICOs, all the kind of the rigmarole that's going on with that, as opposed to really looking at blockchain objectively and saying, all right, if I'm going to use it, why am I going to use it? Where am I going to use it? What other things I have to consider? Who do I need to bring in and things like this? Other cons, and I think some of these cons are really transient. I think some of them are going to, be fixed in time. Scalability is an issue. If you look at the Bitcoin network, 7 transactions or so per second, that's well below what you'd expect as a consumer grade solution. Usability is a big problem right now. Key management. I mean, most mere mortals would have a real difficult time managing encrypted keys, their private keys and exchanging public keys. That's a problem right now. Dealing with crypto wallets, which is part of the gig, is difficult. So I think it's really not consumer grade, and that's a con. I think, from an architect perspective, interoperability is an issue. So if you built a solution, as an example, in Ethereum, and you had some other solution elsewhere in the organization using Hyperledger, well, they're not really going to talk to each other, not without some additional thinking about it. So cross-chain interoperability is an issue. I think certainly identity management is an issue, because there is no such thing, at least in the US, as a universal identity that helps definitively that I am Jim Nasr, and I know definitively that you're, Michael McCarthy. And that's necessary for many use cases, particularly when you're talking about, some of the kind of the patient record management or patient record oriented healthcare use cases that people are talking about. So a number of cons, but I think, like I mentioned, I think many of those cons I see evolving and kind of becoming moot points in a very near future, next year or two.
So you actually architected a blockchain solution, and one thing that you did mention in a con was the scalability issue, and the fact that you can't do currently tons of transactions in a nanosecond. How do you see that being resolved, and was that an issue for you, considering using it for your organization?
Yeah, absolutely. So I think, again, this goes back to my comment about the solution being more nuanced than just blockchain. So part of the scaling problem really goes back to the design of your application. So for a number of reasons, in our world, we have HIPAA compliance as one of the reasons, as well as scalability, performance, things like this. You really have to think carefully about what is actually on the chain, on the blockchain that gets distributed, right? So in our world, we really think of what is on the blockchain as minimum amount of metadata, that and essentially really a hash reference, an encrypted reference to the actual data that is sitting, as on an encrypted decentralized storage. We use IPFS in some of our experimentation. So that's part of the design that they have to really think about is really what is on the chain, because the more you have on the chain, the more that has to be replicated, the more mining power we need, to validate transactions. And we've seen that. So that's a big part of it. But then the flip side, of course, is the more things you have off the chain, the more you have to, secure it off the chain, the more sophisticated solutions are, the more expertise you need to do it correctly. So I think that's part of it. The other part of it really is, I'm a big believer in kind of modern DevOps using Docker containers as an example, and kind of a microservice approach. So that kind of goes back to your application and infrastructure design, which is to say, have you built your software such that it can auto scale, such that it has elasticity in terms of scaling, and you can build some automated rules to help you scale it. Because again, if you don't have that, you're going to hit some scaling issues that are not necessarily blockchain related, but will certainly have an impact in your blockchain solution.
Okay, so since you've actually architected a real blockchain solution, could you just take us through from step one to completion, just kind of giving us the overview, because our students are actually going to be architecting their own blockchain solution. Could you just start with the idea When did you first say, hey, blockchain could help us with this? Could you start us from the very beginning?
Yeah, absolutely. So, as I mentioned to you, I've been personally looking at blockchain and interested in it for a couple of years now. And as I learned more about what we do at the CDC and really the basic, what I think about a business model, basic business model, it turned out that our core business model is what I think of as a many-to-many relationship amongst peers, amongst organizations and institutes that really are not, that you could consider them as partners, as opposed to what I think is perhaps a misperception that the CDC is this giant organization to whom everybody reports. Now, it is true that in many cases, the CDC helps fund initiatives at for instance, state health departments or health partners. But from a business model perspective, we are just a peer amongst those peers. And in fact, kind of contrary to people's typical understanding, the data is actually largely owned by, for instance, by the jurisdiction. So, for instance, if I happen to get sick as a Georgia resident in California, the data, if I happen to say, for instance, contract, I don't know, Zika or something like this, the data for that particular infection and in that particular case actually belongs to the state of California and not Georgia nor CDC. So once I kind of understood this and it became evident that we're a partner amongst many partners, and we have data usage agreements that we have to comply to just like they do, which includes things such as, who can look at the data, who can annotate the data, how long we can keep it, how long, what kind of reporting structure we have. Then I started thinking, well, this actually kind of sounds like a blockchain situation. This sounds like, one of the basic underpinnings of blockchain, which is peers, interacting amongst each other in a decentralized manner, that where, you're doing transactions amongst peers, but it doesn't necessarily mean you know all the peers, nor that you trust them. In our case, either implicitly or explicitly. That's where I started, really. And the more I thought about this, the more we kind of discussed amongst a smaller team, the more it became, evident to us that really we had actually not just one, we had many use cases that we could probe into. And that's really where the thinking got started as a step one. And then the next step really was to figure out, all right, if this is, if this makes sense in theory, what is one or more use cases that we could pick up and actually do a proof of concept? Bring the technologies, bring the subject matter experts, such as the public health experts or the epidemiologists or data analysts, and actually work with them to take the public health use case and lay it out, as technology design, and basically see if we can implement it and see if we can actually prove whether or not it makes sense. So that was the second step, and then beyond that, really what we did was a great amount of research, independent research, as opposed to kind of bringing a quote unquote expert, if you like, like an IBM or McKinsey or whoever. What we decided to do was independently survey the market. We did quite a lot of research. Where we held what we called a CDC vendor showcase, blockchain vendor showcase. We invited 10 vendors to come for a full day. We gave them half an hour each. Startups, folks with people such as Jam or Patientory with a healthcare solution on top of blockchain, as well as service organizations, as well as platform organizations such as IBM and Microsoft, and basically talk to all these entities independently. And then using that, kind of laid out a plan of action on, all right, how do we go about doing this? In the meantime, we figured out one use case amongst several that we had identified. It was around a solution that essentially has a supply chain element where different centers within the CDC provide data that then is published as public statistics on our external website. So there was a real production system. It's called Wander, and it was a real kind of use case, not a hypothetical one. So what we decided to do was to take this and essentially attack the supply chain element, the data supply chain, and conceive that as a blockchain solution, and that's really where it kind of got started. Now, as a next step in this, the question was, and I alluded to this, is really, well, where does blockchain start, in this solution, and where do we have other things and other technologies that need to be considered, and really, and this is again my personal philosophy around this, and I think it applies largely in healthcare. There's a real problem, I think, in healthcare with siloed data. We have many legacy systems, including in the work that I do, where data comes, and that data basically sits. For instance, you could take data for a specific disease as an example, and that data sits in a specific system for that particular disease. But it turns out that really, we need to work across multiple diseases and multiple programs, not just limited to one disease or one specific program. So the first thing was to de-silo the data. So to take the data from these legacy systems and basically expose them through APIs so they can be reached without having to build, individual connectors and individual kind of database solutions for these legacy systems. And we did that, again, outside of the context of this blockchain solution, as part of what I think of as a data as a service architecture. And we use data lakes, and we use indexing, and built our own data abstraction layer, APIs, and things to basically allow us as programmers, or anyone really, to be able to get to data using just an endpoint, using just a URL. And really, so you don't have to know anything about the underlying implementation. It's just a case of giving you a URI or a very simple API, and all you got to do is feed it a couple of variables, and then you receive back data. So that was really the first step, technically, if you like, and that was outside of this blockchain world. The next step beyond that really was this idea. All right, now we have these silos of data, so we can get to it from our kind of abstracted APIs. It's like, well, what data do we really need, and how much of that data really should be off-chain? And the answer in this case was almost all of it. And what elements do we need for searching and really for storing as a transaction marker on the blockchain? And that was the next step. So once we did that, then the next step beyond that in design was, okay, now that we know what's on the chain, what's off the chain, what is our off-the-chain set of APIs? Do we need to create new ones? What is our decentralized storage solution? Because it's a set of peers, and I mentioned this a little bit earlier, that we use IPFS, which is the Internet Protocol File Services, which is a new up-and-coming, I guess, technology, if you like, for decentralized encrypted storage. So we implemented that, as well as blockchain in our network, and set up a proof of concept environment with multiple nodes using IPFS and using blockchain, as well as the APIs that we already had set up on the back end to access the data. That was kind of a rush through the basic thinking process, and how we went from essentially identifying, well, even thinking about what makes sense, or what might make sense from blockchain, all the way to designing it and then building it.
All right. So I got 9 steps out of that. That was excellent. I appreciate it.
Sure.
A few of the takeaways that I took is, well, one, removing all the shiny bit of blockchain, that it's the world's magic wand for everything. I think that's a help, that it's a tool. It's not the entire toolkit. And asking some of the basic questions, do I need it for my problem? Is blockchain actually going to fix it? Is that the best one? If so, how? And then while you're using it, you don't have to use just blockchain in isolation. You could use it with other technologies. Again, using it as a tool as opposed to it's just one standalone solution. Excellent. Now, if we had students who were interested in getting into the blockchain space, specifically architecting solutions like this, where would you direct them to start? Let's say someone they're just graduating college, or they're looking for a career change, and someone's really fascinated with what you do. How would someone get started in your industry?
Sure, that's a good question. So again, I think people are looking for simple and rather effortless answers, and unfortunately, I don't think that's the case. So I think if you want to architect a blockchain solution, I think you need to first really understand what it takes to build enterprise software, right? And like I mentioned, so much of our work really had nothing to do with blockchain per se. It was to do with building microservices, building APIs, doing modern DevOps, security, things like this. And those things are really, I think, if you want to be an architect and build solutions that make sense, you have to understand those regardless of blockchain. There's many good sources. I would say, believe it or not, I think the best, most practical source that you can use starting out is YouTube. So long as you ask the right questions and the right kind of queries, you can find this stuff. There's plenty of really smart people, who freely put out lots of really interesting, both kind of summary level as well as very detailed, talks on the different components that I mentioned to you, such as, this idea of how do you build small interoperable software as microservices. That would be a whole topic, if you like. This idea of modern DevOps, using containers, using what's called continuous integration, continuous delivery, which is really the core of modern software deployment. All of that is already out there. And then specific to blockchain, I think that there's a tremendous amount there. I think, if your students or whoever is interested doesn't already have some level of understanding blockchain, there's definitely some good talks that are a little bit higher level and kind of talk about the why. I'm a big believer, Michael, that you always must ask the so what question, because if you don't, it's pretty easy to drink your own Kool-Aid and pretty easy to kind of, thump your chest and not really be aware of that you're just, you don't really understand in detail what it is that you're doing and why it is that you're doing it. So I think you have to ask that question, and it's a good introspective question to ask. But once you understand the why and understand the business elements, then there's definitely some key things that they can kind of get into from a blockchain perspective. I did kind of basically rush through this, but once we got into, in our case, once we got to the build phase of our blockchain solution, we did not obviously, but I alluded to this, we did write smart contracts. That's how we actually managed to basically codify, if you like, our data compliance agreements. So that's something that you do need to understand, and there's plenty of good YouTube as well as many websites that talk about smart contracts. Again, it's different. If you're building, in our case, we built an Ethereum network from scratch. So that's a whole different open source technology than, for instance, if you go with Hyperledger, which is from the Linux Foundation. So you probably need to pick a protocol. We picked Ethereum. We have another organization at the CDC that's picked and working with IBM, and they picked Ethereum. So you have to pick the right protocol, and then there's, if you go, for instance, Ethereum, to write smart contracts, you need to understand a development tool called Truffle, as an example, and then and then this programming language called Solidity, which is similar to some other programming languages, but it's not the same necessarily as Node.js or Java. That's a little more common. You have to understand it a little bit more, and then also from a user interface perspective, or the actual kind of interface that's interacting with consumers, there's this idea of what's called distributed apps, or dApps, for Ethereum. So again, you have to kind of build those things too. And there's, going back to the germane question, there's lots of really good YouTube videos that I think you can start with. I would say I learned visually, and I think to me, that's a really great place to start. It's not necessarily enough, but more than enough to get you up and running and kind of, get you to the next stage of understanding. And then from there, then you have to ask specific questions of yourself. What is the thing that you need to know more of, and perhaps, look at specific websites or get some training.
Okay, and just on a high level, in your head, what do you see as the difference between Ethereum and Hyperledger?
Yeah, so really good question, and I think it's one that I think kind of gets lost a little bit in the marketing kind of hyperbole that goes around. So let me take a step back, and then you understand the rationale behind my answer. So in the world of public health, my belief is, and as the name implies, it's directly in the name, that public health really ultimately, if you think in blockchain, you need to be thinking about a public blockchain, because disease by definition, is not limited to a jurisdiction. It moves. Public health to really meet kind of our mission of serving the citizens, well, kind of health and wellness, and proactively. And we need to be able to deal with all kinds of diseases from all kinds of different profiles of people in really multiple jurisdictions, including outside of the US. So I'm a big believer that long term, many of our blockchain solutions need to have a public component. They need to be a public blockchain. So, it could be more of a permission public blockchain where, it's not completely anonymized. So we know, for instance, that it's really Jim and really Michael, but still is public as a transaction, and somehow, the encrypted transaction shows just the right elements that protect our privacy, but are useful for exchange of information. So with that being said, the reason why we chose Ethereum is that Ethereum does have a public element. We started with a private, kind of a small private proof of concept, but our vision was that we could essentially come up with a utility token or some kind of a token that could, in time, actually become a public, kind of a public means of attributing value creation, and that value creation being really around exchange of data. So, and a comparison to that with the Hyperledger really is a Hyperledger right now is specifically and entirely an enterprise solution. It's just a private blockchain solution. It's not, you cannot make it a public one. So what that means then is this: if I started with Hyperledger at this moment, and the idea was that we want to evolve it into a public one, that would be a lot more difficult to do, if not impossible, in the current incarnation than it is for me to start with Ethereum, where it is, by design, you could certainly have it as a public blockchain. So that was part of our thinking around this. Other than that, there were a few other reasons. At the time when we started, our thinking was that Ethereum was more mature. There were more independent resources and far larger community around it than with Hyperledger. You probably already noticed Hyperledger, the production version, I think went live in July of this year, 2017. So that was part of thinking, but I think overall though, my kind of thought is that the maturity levels are gonna, and also the cross blockchain interactions are going to be there in a little bit of time. Maybe not next few months, but certainly within a year or two. But this idea of can we take something that by definition isn't really built to be a public blockchain and make it public? That is something that's kind of core to the protocol, and we need to understand that. So that was the thinking behind it. I would say though, from a general evaluation perspective, it is important to understand, where you think the roadmap is going to be, because that is a big part of how you build it. Whether it's one protocol versus another protocol, whether it's using some of the newest protocols such as hash graphs or what have you, or identity management. All those things are really questions that you need to ultimately think about from your business model.
Great. Jim, thank you so much. This has been a huge amount of information. I'm glad we video recorded it.
Sure, thanks. Sorry if it's a little bit of a rush, but so many interesting things to talk about.
Oh, I love it. I absolutely love it. So yeah, thank you so much for your insights. And I'm sure I'll be getting some more questions afterwards, and I'd love to be able to email you if that would be possible. And again, just thank you so much for the time you spent with us. And we wish you a great 2017 and 2018, because we're already at the cusp of a new year. So thank you very much.
Sure. Thank you, Michael. I appreciate it. And thanks for the opportunity.
Take care. Thank you.
You too. Thanks. Bye.